Welcome to Mathematics in the AI Era, a PSC series exploring the mathematical ideas behind artificial intelligence, information, and intelligent systems. In this episode, we begin with one of the most fundamental ideas in modern AI: vectors. The real world contains enormous amounts of information. A computer needs a mathematical way to represent that information. Images, language, sounds, and measurements are therefore converted into numerical forms that machines can process. A vector is a mathematical object with magnitude and direction. In AI, we can think of a vector as an organized set of numbers representing information. These numbers become building blocks of machine-readable meaning. Coordinates normally tell us where something is located. But imagine a space where coordinates represent characteristics rather than physical position. AI uses this idea to place information inside mathematical spaces. A word can be converted into a numerical vector. Words with related meanings can develop related representations. Language can therefore be studied through mathematical relationships between vectors. Once information becomes vectors, relationships can become geometric. Similar concepts may appear closer together, while different concepts may be farther apart. Geometry becomes a tool for representing meaning. Distance between vectors can tell an AI system how similar two representations are. Smaller distances can indicate greater similarity, while larger distances suggest difference. Mathematics makes similarity measurable. The spaces used by AI are usually far more complex than the three dimensions we can visualize. A representation may contain hundreds or thousands of dimensions. We cannot see this space directly, but mathematics can still explore it. Real-world concepts contain many features and relationships. More dimensions give AI greater capacity to represent this complexity. High-dimensional spaces allow models to capture patterns that simple spaces cannot. Vectors are not simply stored, they are transformed. Matrices and other mathematical operations change these representations, allowing neural networks to extract increasingly useful patterns from information. Vector arithmetic can sometimes reveal learned relationships between concepts. For example, some word embeddings show relationships resembling king minus man plus woman equals queen. The deeper idea is that relationships can be encoded geometrically. The same principle applies to images. Pixels begin as numbers, and AI can transform them into high-dimensional vectors capturing visual patterns. Similar images can then be compared mathematically. Text, images, audio, and other data can all be represented as vectors. Modern AI can also align different types of information in related mathematical spaces, allowing connections between different forms of data. When vectors are learned to capture useful properties of data, we call them embeddings. Embeddings encode patterns, meaning, context, and relationships in mathematical space. They are fundamental to modern AI. AI does more than convert information into numbers. It builds mathematical representations where patterns and relationships emerge. In a sense, AI creates a mathematical map of the world it learns from. We have seen how vectors allow AI to represent information. But representation is only the beginning. How does AI actually learn from these representations? That takes us toward matrices, calculus, optimization, and the mathematics of learning. If you found this exploration interesting, like, share, and subscribe to Physical Sciences Consultorium, PSC, for more episodes of Mathematics in the AI Era. See you in the next episode.